for Fourier transform infrared spectroscopy, the spectrum region is between 700 nanometers to 50,000 nanometers. And FTIR is based on radiation absorption. It is based on the concept of radiation absorption in the IR region. Next, FTIR is commonly used in the biochemical industry, mainly to determine compound presence or absence of functional group and the structure of molecules. FTIR is one of the techniques for qualitative analysis. It involves transitions among the vibrational energy levels of the lowest excited electronic energy levels of molecules. In the FTIR spectroscopy, we mainly use the FTIR spectrophotometer to analyze samples, and there are 5 sample analysis process. The first one is the source. Infrared energy is emitted from a glowing black body source. This beam passes through an aperture which controls the amount of energy presented to the sample. Next, we have the interferometer. The beam enters the interferometer where the spectral encoding takes place. The resulting interferogram signal then exits the interferometer. The third one is the sample. The beam enters the sample compartment, where it is transmitted through or reflected off of the surface of the sample, depending on the type of analysis being accomplished. This is where specific frequencies of energy, which are uniquely characteristic of the sample, are absorbed. The fourth one is the detector. The beam finally passes to the detector for final measurement. Detectors used are specially designed to measure the special interferogram signal. And the final step is the computer. The measured signal is digitized and sent to the computer where the Fourier transformation takes place. The final infrared spectrum is then presented to the user for interpretation and any further manipulation.
So, basically this is graph produced from FTIR spectrometer. So, I'm going to explain you how to get the molecular formula involved from the FTIR spectrometer. So, given molecular weight equal to 142. So, we will use the major peak involved here. Then, based on the table, so we find the wavelength, and sometimes they also given wavelength. So wave number is 30,003. So we find in the table given, so it is CH stretching. CH stretching. Next, the second one is at 1500, also at CH bending. So basically we know the element contain C and H only. So based on the molecular weight given, we try to assume the molecular formula. So carbon 12, hydrogen equal to 1. Let we say that carbon 6, H12. So the answer given is 84. So it's more than 6. So we try with C10H22. So it matches with the molecular weight. So then we try to draw the molecular formula. From the molecular structure. So the number of H basically match with the molecular formula. So it proves that C10H22 is the molecular formula for this graph.
That's all, thank you.
That's all.
In a nutshell, FTIR is a powerful tool that is used to determine the molecular compound, the absence or presence of functional group, and molecular structure. Besides that, it is a very effective tool because it has a high sensitivity, as it is able to identify even the smallest of contaminants. Furthermore, it is a very fast method to measure samples because the frequencies are measured simultaneously. And finally, these advantages makes the Fourier transformation infrared spectroscopy an extremely accurate and reproducible method.